Chapter 14, review for test. Question number 1 says, a straight glass rod appears to bend when placed in a beaker of water, as shown in the diagram. What is the best explanation for this phenomena? So it's just refraction. So the glass rod appears to bend in the beaker of water because of the refraction. The light bends when it travels from one medium, air, to another medium, water, causing the image of the glass rod to appear shifted at the water's surface, making it look bent. So the answer to number 1 is D, refraction. So the key there is just refraction. All right, number 2. The diagram below shows a ray of light being refracted as it passes from air to glass. So the first thing you want to write down is you're going from air to glass. Okay, because that's important. So now we're going to start thinking about the density. So air is less dense and glass is more dense. So the first way that we remember the rhyme is, it's not a rhyme, but it has a name, is we said to remember this doesn't match up. There we go. We said to remember MLA up. So this means I'm going from a more dense to a less dense. I'm going to bend away from the normal and I'm going to speed up. But that's not what's happening in this case. We're going from a less dense to a more dense. So whatever the opposite of this is, so instead of M, it would be L. Instead of L, it would be M. Instead of away from, we have T for towards, and then in speed up, it's going to be slow down. So instead of up, you should really just put, so this is up, this is down. So whatever this is, this is what you memorize, this is the opposite. So in this case, we're going from a less dense to a more dense. We're going to bend toward the normal and we're going to slow down. So now it says, which letter is the angle of refraction? So this is the normal ray going straight, but since it's going to slow down, it's bending towards the normal, so the answer is D. So first of all, this is the incident ray, so those two are wrong. So it's either C or D. So C is bending away, D is towards. When a wave enters a medium of higher refractive index, its velocity. So velocity means, is it going to speed up or is it going to slow down? So it says it's entering a medium of higher. So the index, so it's entering a higher refractive index. So a higher refractive index means it's more dense. So I'm going from a less dense to a more dense. I'm going to bend towards the normal, and I'm going to slow down, which means that the velocity, the speed, is going to decrease. You just have to think about it. All right. All right, let's look at number 4. So it says the speed of light in a medium is 2.0 times 10 to the 8 meters per second. The index of refraction is, so the speed of light in the medium, that's V sub S, the speed of light in a medium. And now we want to find the index of refraction, N. Okay. So the equation that we're going to use is N of a substance is C over V. So this is the speed of light in a vacuum, 3.0 times 10 to the 8 meters per second. divided by the speed of light in a substance. You don't even need a calculator because these are the same exponents. 3 divided by 2 is 1.5. Number 5, the apparent speed of light is least in, so Canada balsam, that's just wood, diamond, lucite, or alcohol. Well, remember, N is equal to C over V. So V, the speed, is going to be C over N. This is 3.0 times 10 to the 8 meters per second. Now, you're not going to sit here and write all the numbers. The larger this number is, the smaller this number is. So when you look at the chart, you know that a diamond has the greatest index of refraction, so the number in the denominator will be the greatest, so the speed will be the lowest. So it's going to slow down the most in a diamond. Number 6, the diagram below shows an arrow placed in front of a converging lens. The lens forms an image of the arrow that is, well, here's, I went parallel through F, through the center. I don't even have to draw the lines. There's my image. So now, with my image, I need to say, remember, here is the object. So this is virtual and this is real. This is also upside down, which is inverted. So I'm going to cross off these two because it's not erect. So it's either real or inverted or virtual. And the answer is real and inverted, A. Number 7, which type of images can be projected on a screen? That's only real images. Which type of images can be formed by a converging lens? So a converging lens is the one that the rays of light converge, which means to come together. So that's the scenario that we did the ray diagrams in class, where you can have 6 different situations, so they can be real or virtual. That's converging. Remember, diverging is the one where you're only going to have virtual. All right, so let's move on to the next page. Oh, we're almost done. Yay. All right, number 9. The diagram below represents an object. Where's the other page? Placed 2 focal lengths from a converging lens. At what point would the image be located? All right, so why is this different than that? What you do is, we're going to go through, you can do it by hand, but we can do it also with a straight edge. Don't have a ruler. All right, so we're going to go to the top of the object, and we're going to draw a line. Okay. And then we are going to, so we went through the center. Then we're going to go here, and we're going to go parallel. And then we're going to go through F. My son's business card. A lot of information there. And where the lines converge, that's where we have our image. And I drew, it actually is right here. Okay. So where is it going to be located? It's going to be located at D. And even if I was a little off, you see, because we're doing it freehand, your choices are A, B, C, and D, and D, it's going to be the closest to D. All right, photographers sometimes use colored filters to restrict the light entering a lens to a single wavelength. The filters are used to eliminate. So again, here, it's something called chromatic aberration, D. Number 11, which phenomena allows a lens to focus light? And that is refraction. All right, number 12, we finally have a problem. So it says an object, so when we do our problem, remember, we're going to write our given and find and everything else. So it says an object is located 0.5 meters from a converging lens. So the distance of the object is 0.15 meters. The focal length is 0.1. How far from the lens is the image formed? So I want to find DI. So my basic equation is 1 over F is equal to 1 over DI plus 1 over DO. If I rearrange the equation, which happens to be on our equation sheet, DI is equal to DOF over DO minus F. So it's 0.15 times 0.10 divided by 0.15 minus 0.1. So this comes out to be 0.15 divided by 0.05, which comes out to be oops, I'm off the paper. So DI comes out to be 0.30, which is choice D. All right, number 13, it says an object is located. So again, we want to write down our information. It's 0.4 meters in front of a lens. So that's the distance of the object. The focal length they're already telling you is negative 0.20. And now it's asking you, compared to the object, the image of the lens, and it's like, how are you supposed to do all this? So we're still going to do the math. So if I do the math and I say DI is DOF over DO minus F, that's going to give us the distance of the image. If the distance of the image is positive, that means it's real. If the distance of the image is negative, that means it's virtual. So when I substitute it in, 0.4 times negative 0.2 over 0.4 minus negative 0.2, I get negative 0.08, and a negative is a positive. So DI comes out to be negative 1.33 meters. So what does that mean? So the negative DI means that it's virtual. If the DI was positive, that means it would be real. So that's how we know from the math. Now, how about the next part? So that tells me it's virtual. So because it's virtual, I can cross off A and B, but what about C and D? Now it's asking me if it's larger or smaller. Those choices are both correct, so how am I going to know? Well, that's where I'm going to do the magnification. So the other equation is magnification, HI over HO is negative DI over DO. Well, they didn't give me HI or HO, but I know this. So negative 1.33 divided by 0.40, and when I do that on my calculator, the magnification comes out to be 0.3325. So magnification means larger or smaller. So the magnification is about a third of the original object. So because this is less than 1, this means, so this is less than 1, so this means this is smaller than the original object, because magnification is a ratio of the image distance to the object distance. So because it's less than 1, then I know it's smaller. So here I knew the answer is C. If I wanted to know if it was erect, if this is positive, it's erect. If the magnification is negative, that means it's inverted. So the magnification can tell me two things. Is it larger or smaller? Is it erect or inverted? Number 14, the image formed by a diverging lens. So diverging is where the rays of light spread out. And those are always going to be virtual, always. So just like when we did mirrors and we did convex were always virtual, diverging lenses are always going to produce virtual images. And the last question, it says, which diagram most accurately represents the behavior of light rays passing through a glass lens in air? So first of all, we didn't even do these other ones, okay? We didn't even do these. So these are both diverging lenses. So here's the light coming in. Remember, diverge means to spread apart. Diverging lenses are going to cause the rays of light to spread out. So this is correct. And that's it. And we all get 100 on the test.